Hi Year 12, welcome to an exciting class on projectile motion, the last topic for the entire course. So let's get into it. First of all, projectile motion is basically when you throw something. It's going to create the shape of a parabola. We fire off at a particular speed, at a particular angle, and we get a parabolic shape. Sometimes you could actually be on top of a cliff and you could throw something off a cliff and it could look like that, and that's fine too. But that's what projectile motion is talking about. Now, when we deal with projectile motion, we're going to break the direction of the journey into horizontal parts and vertical parts rather than working on diagonals. Now, first of all, let's talk about our initial setup because this is important. This is going to set us up for our proofs. If a particle is projected with a velocity of v at an angle of theta to the horizontal, it follows the path of the parabola. Now, and it follows the path of a parabola. So here's our example here. We've got a y-axis and an x-axis. If the particle, or the projectile, sorry, was shot off at an angle of theta, and this is our answer here, it doesn't stay at theta, it follows a parabolic arch, but at the beginning it shot off at a particular angle with a velocity. Now, technically, you could probably put this, it's a velocity, but we often just use v. And we're going to break the velocity up into a horizontal part and a vertical part. So really, what we're saying is this, that you could start here and go in that direction, or you could start, go across and go up, but you're going to end up in the same position. So it's easier to work horizontally and vertically than it is to try and work diagonally with angles. Let's talk about our horizontal situation. If I look at our triangle over here, there's my angle. If I do the cos of theta is adjacent over hypotenuse, that would give me cos theta equals the horizontal velocity over the main velocity. And if I rearrange that, I get the horizontal velocity is your original velocity multiplied by cos theta. Similarly, if I look at the vertical scenario, the sine of theta is opposite over hypotenuse, so I get sine theta equals the vertical velocity over the original velocity, so the vertical velocity is the original velocity times sine of theta. Now we need to remember these two things. We're going to use that we know that initially, at the very beginning of the scenario, when we shoot off our projectile, that the initial velocity is in the horizontal direction, v cos theta. The initial velocity in the vertical direction is v sine theta. Okay, so let's have a look at our question here. Horizontally, we know there's no acceleration. When you shoot your projectile off, the only acceleration that acts is gravity, and that's vertical, it's up and down. So to find the horizontal displacement, we're going to start by saying horizontally the acceleration is zero. There's no left and right acceleration. And then we're going to integrate that once to get the velocity and integrate it again to get the displacement. So we look at this particular question and we say, horizontally, the acceleration is 0. I'm going to actually mark that one in a box because that's important. Let's go to the next part. Horizontally, we've got the integral of 0 with respect to t will give me the velocity. Let's integrate 0 with respect to t, and I'm going to get the velocity is equal to, when you integrate 0, you get a constant. Now, we also know that at time 0, the velocity is equal to v cos theta. We did that with our little proofs before, which means at time 0, x equals v cos theta. If I plug that into this scenario here, I get v cos theta equals c, which generates the horizontal velocity is v cos theta, where v is your initial velocity that you are firing off at an angle. That's the second thing. So now I've got the acceleration, I've got the velocity. How do you go from velocity to displacement? You integrate again. So let's go through the process again. To find an integral again, we're going to go x equals the integral of v cos theta with respect to t. So x will equal, if we're integrating v cos theta, that's just a constant, so it's going to become v cos theta times t, and I'm going to write it as vt cos theta plus c. But we also know at time 0, its position is at 0, because when you shoot something off, we're shooting it off from 0, 0. Which means if that's the case, if we put in time 0, x 0, that's going to generate a c value of 0. So x equals vt cos theta. And I'll highlight that one. So what I've actually done is I've generated 3 different formulas. 1, 2, 3. Acceleration, velocity, and displacement, all in a horizontal direction. Now we're going to do the same, but we're going to do it in a vertical direction. So if we look at vertical motion, there is an acceleration. It's called gravity. So it's going to affect what's happening vertically. Now because we're actually heading downwards, gravity is actually going downwards, we're going to put acceleration is negative g. So let's start off by saying our acceleration vertically is equal to negative g. There's our starting equation. To go from acceleration to velocity, we need to integrate. So I'm integrating minus g with respect to t, which will give me minus gt plus c. But I do know from what I did earlier that the initial, so when t equals 0, the initial vertical velocity is equal to vt sine theta. Oops, sorry, no it's not. It's equal to v sine theta. Let's get that right. Which means if I plug in t equals 0, I get y dot, so I'm going to get the vertical velocity is equal to c, v sine theta equals c. That means my vertical velocity will equal minus gt plus v sine theta. And there is a second piece of work. Now I want to get the vertical position or vertical displacement, so I need to find y. So y is equal to the integral of minus gt plus v sine theta with respect to t, which will equal, now we're integrating with respect to t, so minus gt will become a squared over 2. V sine theta, when I integrate that, becomes vt sine theta, because v sine theta is just a constant, plus c. That's what y equals. Now, we know that at time 0, it hasn't gone anywhere, so y is equal to 0 because it's on the ground still. So, but when t equals 0, y equals 0, and if I put all of those zeros in, that's going to imply that c will equal 0, which gives me my final statement that y is equal to minus gt squared over 2 plus vt sine theta. And there is another rule. Now there are 6 rules there. Each of those rules will give you either horizontal or vertical acceleration, velocity, or displacement. In an exam situation, you will need to have to prove them from scratch every single time. Now, for the rest of this question, because I don't want to keep proving it for every example, you've got to go through this process again, I'm going to refer to my equations as equation 1, 2, 3, 4, 5, and 6. So they're the 6 equations that I'm going to be referring to. And if I refer to equation 6, it means I'm referring to this one. If I say equation 4, I'm referring to this one, and so on. So I'm going to leave this slide in a moment, but when I talk about equations 1, 2, 3, 4, 5, or 6, you can see which ones I'm actually going to be referring back to. So let's continue. So we're going to set up an equation now. It's called a Cartesian equation because it's going to have x's and y's in it, something we can graph. And what we're going to do to find the Cartesian equation of our motion, we're going to look at the horizontal and vertical displacements because horizontal and vertical displacements are x and y. Then we'll solve simultaneously to find out our equation. Let's actually go through this process. So we're going to start by saying, well, let's write down what the first equation I want to use is, and that's x equals, so it was equation 3, v t cos theta. There's our equation there. We also know, think back to equation 6 on that previous slide, that y is equal to minus gt squared over 2 plus vt sine theta. So they are 2 equations that we got, equation 3 and equation 6 from before. But for the rest of this question, I'm going to refer to them as equation 1 and equation 2. So what I'm going to do is I'm going to rearrange equation 1. And if I rearrange equation 1, I can get it to say t equals x over v cos theta. So I just divided by v cos theta to both sides. So I'm going to now substitute t equals x over v cos theta into y is equal to minus gt squared on 2 plus vt sine theta. So everywhere I see a t, I can put something in its place. So I will get y equals minus g x over v cos theta squared all over 2 plus v x over v cos theta times sine theta. So hopefully you'll notice that everywhere I saw a t in the line above, it got replaced with x over v cos theta. Now I have to go through the expansion process for the squareds. So we get minus g and x gets squared, so it'll become x squared over, well, let's actually tidy that up. I can go a little bit faster and hopefully you understand what we're doing here. The x is going to get squared, and so is the bottom of the fraction here. The v cos theta will be squared, so I'll get v squared cos squared. But because that's on the bottom of a fraction, it's going to go down here. So I will get over 2 v squared cos squared theta plus, now when I look at this, I can see there's a v and there's a v. They'll cancel each other out. And I've got a sine theta over a cos theta. Sine theta over cos theta is tan theta. So it's just going to simplify down to x tan theta. So that's what y is actually equal to. Now, cos squared is on the bottom of the fraction here. If I move the cos squared up to the top of the fraction, it becomes a sec squared, because what you need to recognize is 1 over cos squared is equal to sec squared. So I can actually write this as y equals minus gx squared over 2v squared times sec squared theta plus x tan theta. Now let's think back to our rules. If we go back to trigonometry rules, we actually know from former questions that sec squared theta equals 1 plus tan squared, or tan squared plus 1. And I'm going to use that rule to give me my next line. Y is going to equal minus gx squared over 2v squared, 1 plus tan squared theta, plus x tan theta. And that there is the formula that we often refer to as the Cartesian equation of motion. So that's how it's generated. You take your formulas for x and y that we did for our basic rules. Remember the 6 formulas from before? We took formula 3 and formula 6 and we just solved it simultaneously and generated an equation that's got x's and y's, acceleration due to gravity, v is the velocity that it's fired off at, and theta is the angle that it's fired off at. Let's continue our journey. So now we're going to look at the time of flight. Now what that means is this. When you shoot something up, how long does it take before it hits the ground again? That's called the time of flight. And we have a formula that generates that, and the way it works is this. And you have to do all of this by first principles. You have to recreate the formula every single time you do these questions. To find the formula for the flight time, you look at the vertical displacement. That's how high it is above the ground, and you say that's 0, because what actually happens is this. When you shoot something, it's on the ground at 2 points, at the beginning and when it lands at the end. And if you can zero in on this point here, you can generate or find out how much time it took to complete our little journey. So we're going to start with the following equation, and the equation is our y value. It was equation 6 on the ones that we originally had, so let's write that down. So it's y equals minus gt squared over 2 plus vt sine theta. Now that's the equation, and we're going to take that equation and we're going to make y equal to 0. Then what I might do is take out a common factor of t, because t is what I want to get by itself. So let's take out a common factor of t, and that'll leave me with minus gt over 2 plus v sine theta. Now if I solve that equation, remember there's 2 parts being times together, so either t equals 0 or that bracket equals 0, so when you multiply them together I get an answer of 0. So t will equal 0, or it's a bit hard to read the answer off instantly, so let's write the bracket down. Minus gt over 2 plus v sine theta would equal 0. The bracket would equal 0. And I could move the v sine theta over to the other side. So minus v sine theta. Now I'm going to multiply both sides by 2 and divide both sides by minus g at the same time, which will give me 2v sine theta over g. And this minus here, when I divide by minus g, will cancel with this minus here. So there is our formula. That is the formula that we are going to be able to use now to find the time that it takes to complete our journey, to hit the ground again. All we need to know is the angle that it was fired off at, the velocity it was fired off at, and the acceleration due to gravity, which we already know. It's 9.8 meters per second squared, or it's going to be approximately 10. The question will normally tell you what value to use. So let's continue. We've got 2 more that we need to actually work with before we do some specific questions. So now we're going to talk about maximum range, and that maximum range just talks about how far your projectile carries. So here's the ground, you shoot your projectile off, and the maximum range is the distance that it travels, and we need to find out that particular value. So how do we do that? Well, what we do is we do the horizontal displacement x equals, and we're going to call x r for range, and y 0. Now why would you choose y 0? Well, let's just think about that again. I'll draw that again. If I draw this, this would now be the point r, comma, 0. This would be the point 0, comma, 0, and r is the distance out to there. So what you're doing is you're letting x be replaced with r, and you're letting y be replaced with 0 because you're back on the ground and your y value is 0 because you're not in the air anymore. And that's how you're going to generate this particular formula. So, how are we going to start it off? Well, it does say here, we start off by saying, we'll use the horizontal displacement. Well, let's use a horizontal displacement. Now that was formula number 3 from the original ones that we had, and it goes like this. X equals Vt cos theta. That's our formula for horizontal displacement. Now, we've also said we're going to let x be replaced with r. So r equals Vt cos theta. And r stands for the range, remember. So I'm going to call that equation 1. Now, what I might also do is look at the formula for what y is equal to. Now we know y is equal to minus gt squared over 2 plus Vt sine theta. Now we're going to let y equal 0 because when it hits the ground, it's 0 meters off the ground. So there it is there. So if I look at that, I take out t as a common factor, which is very similar to what I did before. I find that t could equal 0, or t could equal v sine theta to v sine theta, and I'm going to be timesing that by 2, so I get 2v sine theta over g. That's for the time that it takes to do the complete journey, which is what we found in the previous question, but I'm going to call this one here piece of information number 2. So let's go and substitute 2 into 1. And if I do that, I get r equals v instead of t, 2v sine theta over g cos theta. Now let's have a look at what we can do here. If I actually multiply that out, I've got a v and a v, and when I times those, I'm going to get v squared. I've got a 2 sine theta cos theta. Now, 2 sine theta cos theta is just another way of writing, if you remember, the sine of 2 theta. So I'm going to say it's v squared sine 2 theta over g. And that is the formula to find how far our projectile travels, its maximum range. Right, we have one more thing to look at, and then we're done with the generating the formulas that we're going to be requiring for these questions. And that is, how high does your projectile get? Well, to do a question when we're involving the height, the highest point is going to occur when your vertical velocity is 0, because it goes up, it stops, and then it comes down. So at its highest point, it's not moving vertically, it's stopped to turn around and drop back down. So we're going to find y dot, or the vertical velocity, and make it equal to 0, and we'll work with that. So what is the formula for y dot? Well, let's write a few things down first. So, maximum height occurs when your vertical velocity is equal to 0. Now, what is the vertical velocity? We know the vertical velocity, if we go back and look at our formulas, that was formula number 5, minus gt plus v sine theta equals 0. Rearrange that, and we will get t equals v sine theta over g. V sine theta over g. So rearranging to get t by itself. Now, to find the maximum height, I call that 1. To find the maximum height, I'm going to substitute 1 into, so, for max height, we're going to sub the value for t into y equals, now this was formula number 6, minus gt squared over 2 plus vt sine theta. So where I see a t, it's going to become minus g over 2, and the t gets squared, so it's v sine theta over g squared plus v sine theta over g sine theta. Wow, that looks like quite a mess. Let's see what actually happens if we look at this. Now, when I look at this first part here, this is all being squared. So v, when I square, it's going to give me a v squared. I've got a minus out the front, so I'm going to have a minus v squared sine squared. What I haven't dealt with is this g, but I know there's a g on the bottom here. So on the bottom, this g is squared, and so one of those g's will cancel with the g on the top, so I'll end up with over 2g plus, now when I look at this, I have a v and a v, they'll give me v squared, a sine theta, that'll give me sine squared theta, so it's v squared sine squared theta over g. Now if I want to, I could actually think of this as being times top and bottom by 2. That gives me a common denominator of 2g. I can add the two top parts, so I can add this part and this part. 2v squared sine squared, take 1v squared sine squared equals v squared sine squared over 2g. And that is the formula that will give you the greatest height. So, let's summarize everything we've done. There are all the formulas that we dealt with. Our horizontal and vertical displacement, velocity and acceleration. Remember, you start with acceleration and you integrate them to get velocity. You integrate the velocity to get the displacement. To get the equation of your path, you look at these two horizontal and vertical displacements and solve them simultaneously. It generates this one here. You can get your range, your maximum height, and your time of flight from using these formulas as well. And that's what we've just completed doing.